Moving on, guys, we're going to talk about inverse relations. So if we think about a function, okay, we could think about a function this way. So some function that does this. So we have a bunch of values. So I don't know, 3, 8, and 10. These are the inputs to our function, and then our function will map them, I suppose, to the outputs. So these are the inputs, these are the outputs. And the outputs, you know, if you put in 3, you might get 10. If you put in 8, guys, if you put in 8, you might get 4. And if you put in 10, you might get 15. Okay? Function doesn't necessarily have to use some sort of formula. It could just be a list of values that match up to another list of values. Okay, the point is, for a function, each input gives you an output, gives you one output. So there's no 3 gives you 10 or 3 also gives you something else. Okay? Now, we can have what's called an inverse. So this is called a mapping. Okay, we sort of say 3 maps to 10 and whatnot. So we could also define an inverse mapping. So an inverse mapping of this one we would get these inputs now. So 10, 4, and 15. So if we had some sort of relationship, or could be a function, might not be a function though, but it would, if you gave it a 10, it would do the opposite, and it would give you a 3, an 8, or a 10. So this is called an inverse mapping. So you guys get the idea of an inverse? So inverse is the opposite, I suppose. So if you had a function, let's talk about functions again. If you had a function that you wanted to find the inverse of, so if we have, a function, in this case, f of 3, what does f of 3 equal to? 10. So this maps from a 3 to a 10. Okay? So what this means is if we were to graph this, what would the point be? 3, 10. Okay, because this is our x value and our y value. Okay. Now, if we were to graph the inverse of it, we would be graphing f of 10 is equal to 3. So again, we have our x and our y, but they're opposite. Okay, so the point that we have is 10, 3. So what do we notice about these 2 points? They are different. In what way are they different? I've swapped the x and y's. They're opposites. Okay, so if we have any function, okay, I want to know how I can come up with this inverse mapping for any function. Okay, so let's use a function we were using just before. Let's let f of x equal, was it 5x take 2? Okay, I want to know what my inverse relationship is. So what's my inverse relationship going to be? What am I doing here to get my inverse relationship? What's different from here to here? It's swapping them. So swapping my x and my y. Okay. So I'm going to say, well, this is equal to y is equal to 5x take 2. So if I want to find my inverse, so this is my original function. My inverse is when I swap my y and my x. So my inverse relationship between these two variables is going to be x equals 5y take 2. So I've swapped the x and the y. Now, how do I normally write a function or a relationship with y first? So if I'm doing this, I need to rearrange it to get the y on its own. So I'm going to go, well, that's add 2 divided by 5. So y is going to be x plus 2 divided by 5. Okay, and now, is that a function or is that just a relation? That would be a function. Okay, so because this is a function, I can call this my inverse function, which is called f to the negative 1x. Okay, my function f to the negative 1x. Now, have we seen this before? Are you sure? Sine? Yeah. So sine, cos, and tan. So you've seen this little notation before with sine inverse, cos inverse, and tan inverse. And that's because I don't have a calculator handy. That's a shame. Does someone have one I could? Thanks. See who? All right. So let me just let's say I have sine. Someone just pick a number, any number that I can put in. 46. So if we do sine of 46, and this won't matter if it's in degrees or radians, I just want the output. This is approximately 0.719. Okay. Now, if I swap the x and the y, so this is like my x and my y. So if I have my inverse function and I put in my y, I'm going to get out that. So if I go sine inverse 0.7719, it's nearly equal to 46. Obviously I rounded off there, but that's roughly 46. Okay, so your inverse function, it swaps the x and the y, and that's how you do it. Okay, so I might do another example of this just quickly. I'll come back to that page if you missed those. Let's find the inverse of f of x is equal to x squared take 3. We're finding the inverse of f of x equals x squared take 3. So this is going to be y. So y is equal to x squared take 3. So the inverse, what do I need to do to find the inverse? Swap the x and the y. So x is equal to y squared take 3. But I need to rearrange this function to get y on its own. So I add 3 to both sides and take the square root. So y is going to be x plus 3, and I have to take the square root. Now what do I need to remember when I take the square root? I've got the plus minus there, so I've got 2 values. So is that actually a function? No, that's not a function. So the inverse relation is y equals x squared, y equals plus minus root x plus 3. Did I say that right? That's the inverse relationship there, but it's not a function. I'll point out one last thing before I finish, and that is if I were to graph these, because we've done this graphing, so this function looks something like this, except it looks like symmetrical, ignore that. And then this function, this is a square root function, moved how much to the left? 3 to the left. Okay, Now, because I've swapped the x and y's, just come and sit down. Inverse functions, and if I graph this on Desmos, it'll make more sense, is they're actually symmetrical along x equals y. And I'll show you in Desmos. It's due down to that swapping the x and y. All right.